Wow. Forgot to put the cameras on. I'm here messing about trying to sort everything out. I forgot to put the cameras on. Hopefully you got audio. Because I couldn't hear anything when it booted up then for some reason. Let me just chuck this camera on as well. Make sure that works. Hopefully it does. Dear oh dear. Yay. How are we doing, everybody? For some reason I can't monitor sound again. This thing's random, isn't it? I don't think it's a computer. I think it's OBS, you know. It does some strange stuff. Hopefully you can all hear me anyway and see me now. I've turned the cameras on. Oh, I don't believe that. Right, we've got loads in. We've got Tim in first by the look. So Aaron in and out. Doing a bit of gaming. Joe's in. I'm in. Nick. We've got Nick. A bit cold. Cold down Joe's neck of the woods. -17. Flipping heck. How do we survive, eh? Aaron's back. Successful gaming. Kim, how you doing, Kim? Paul's in. -5. I'd say we've had some wind and rain here recently. I think we got some rain coming in overnight tonight, early hours and into tomorrow. Tomorrow? What's tomorrow? Ben, hi Ben and Bob, a Grundig Ocean Boy 820. Derived from the Minerva. Never heard of that, Bob. Peter, good afternoon to you. Stream Elements was in. Benji's in. Hi Benji. Oh, hang on. It's jumping. 6 degrees in Scotland. Hi Joe. Brilliant. Thank you, Aaron. Beer in the pip. Yeah, this is the exploding beer. This is the same one. You want another one, Paul? No. I'm hoping this is good. Mrs. Cruncher is on the mend. She went back to work last week and is a lot better. Thank you very much for asking. Tom and Susie, how are you? And Mary Susie's sister. Welcome to Mary. J Fix, how you doing, James? Beer and radio, yeah. Yeah, I don't know if you've seen it last week, James, but when I cracked the beer open, it literally exploded everywhere. I was spraying it on everything. It was mental. So I must do a little short of that, mustn't I? Rampton, how are you, mate? There we are. I think I've said hello to everybody. Apologies if I've missed someone, but I don't think I have. You never know. You never know. I had a bit of a tidy up. Bit of a big tidy up yesterday. I've got space on the bench. I've got space on the floor. I can get to my other bench because I've been doing my accounts. They're nearly done. So I've got some things on the bench all lined up, as you can probably see. No audio on this for some reason, but you can hear me, so that's fine. Evan, how you doing, Evan? Welcome to you, Evan. Chris is in. How you doing, Chris? So we need to open this, but I'm scared. Now, I did have a warning in from John. What did John say? I had a message, I think, this morning from John. Yes. John's going to try and join us today, but he might be a little bit late, and he's asking for no beer fountain today. Jeff's in. Hi, Jeff. Right. Dare I try and open it here live? Got to, haven't we? We got it. Here it is. Same stuff as last week. Flax New Forest Classic IPA explodes on release of the top. So this week I've had it in the fridge, as you can see. It's had a week to rest. I hope it doesn't go everywhere again. Let's just move this back out of the way a little bit. Let's move that out of the way. What sort of shield can I get up by the computer? Are we ready? Let's zoom out a little bit, just in case. Oh no, Derek, how are you, mate? It contains IPA. What incendiary devices? Let me open it this way this time, so it's aiming at me, not all over the computer and the bench. Whoa, it's going again. It's going again, I don't believe it. It's going again. No. Can't be that feisty. Whoa. That's a feisty beer. I mean, that's fairly uneventful compared to last week. Now, where's my blue roll gone? There's some blue roll here somewhere. Fairly uneventful, but still a bit feisty. Yeah, hi Derek. Yeah, I got me broken toe still. I've been struggling to get around a bit this week. Surprising, isn't it? Your little toe really does nothing, but when it's when you've killed it, it certainly hurts. So I've been hobbling around this week. Still not much improvement. The swelling's gone down, but you know, apart from that, I'm okay. Not got any more lurgy. And how are you, Derek? Everybody asks how I am, but how are all of you? Whoa. I haven't replayed last week's video yet. I literally haven't had time. It's been a busy week this week. That is one feisty beer, that. So thanks for sending that along, John, if you're looking at it. Head dwarf successfully defused, yeah. Only just, though. You know, it was a fairly good. Oh, cocoa. Yeah, I do need a beer towel. We need a Radiocruncher branded beer towel, don't we? Or bar mat. Anyway, cheers everybody. Yeah, Coco's toe. Back to the vets he's been again this week. Not great news. He's got a different antibiotic this week, and I think if he's got 10 days, if that doesn't work, they're going to chop his toe off. So me and Coco both got toe issues. Both got toe issues. I did say cheers, didn't I? Beer tube. Still no sponsors though, Peter. Az, how are you, mate? English. We do make beer, Peter. It's amazing, isn't it? We do make beer, and it's not all the warm fizzy stuff, or the warm flat stuff. That's certainly not warm, and it ain't flat either, is it? Anyway, this is what we're going to look at today, the Hacker Helmsman, and we're going to have a look at the alignments on it. Couple things. Firstly, we changed the IF. Now I have pulled the little cover off of this, or the little ferrite off the top of it. There's a little block of 2. And did I chuck it back in there? Yeah. Is it ferrous or is it some? I don't know if that's a metallic. Yeah, it is. So it's like a ferrous cap that's sat over the top of that, if you remember. And then you've got the little shield that goes on top of it, like that. So that's your what you see in the radio is just that, but inside it you've got 2 coils. Now it's still open circuit. I've got it on the bench because I want to show you something in a minute when we start doing the alignment on this. So because we've changed that, we are highly likely to have messed up the IF on it. When I say messed up the IF, I mean the sensitivity, the amplitude, or whatever you call it. It's not going to be peaked. It's going to need peaking. So I've got sort of everything sort of pre-set up. Now in the background, up here, you notice my old Marconi output meter. There's a bit there. Look. So that's connected to the speaker terminals. There's no speaker in the set, so you don't have to hear that horrible. Now it says 400 Hertz tone. For some reason I can't get my signal generator will do 400 Hertz tone, but I haven't been able to work out how to do it. I just can't. As soon as I turn on the tone, it automatically defaults to 1 kilohertz. I can alter the modulation frequency, but I don't know that I can do it in AM mode. As you can hear, it's 1 kilohertz. That's 400 hertz, but that's only 5%. Oh, I might be able to do it. So it needs to be 30%. I've got to do it manually by the looks of it. Okay, looks like I can do it. I mean, you can't see what the hell I'm doing because I'm twiddling knobs on this massive great thing over here, which is my communications test set, which is a fantastic bit of kit. If I knew how to work it, it would be even better. But I know enough to do what I need to do. So if I turn this set on, I've got my little thing set up here. So yeah, you can hear that tone coming through the radio now. If I turn that off, or down to low, and pump the volume up, turn it back a bit, you'll be able to see the output meter moving there. So that's measuring the signal strength coming out. So if I was to bump a bigger signal in it, you can see it's off the charts. So I've got to put a small signal in it. And the idea is when we trim the IFs, we should see this needle going up. So that's the plan. That's what we're doing anyway. Baz, how you doing, mate? Heathkit. Yes, this is Marconi here, but the test set here is Stabalock. I've got some Heathkit stuff knocking about. Well, my capacitor tester is Heathkit. So we need to get lots of bits of kit involved here so you can see what the hell's going on. Let's see if I can get the overhead camera in the situation. so I can show you what I'm doing while I'm altering the. I'll do that. Let me have a quick look at the overhead camera. Yeah, so I need to put that one picture in picture, really. Main camera picture in picture. Webcam. Okay. Yeah, I'd need to make up another slide to get it all in the shot at once. But this is the IF can, so it goes that way. So we've got to adjust these two first, then these two, then finally that one. That's the last one. And we're going to adjust them for maximum amplitude on the Marconi meter. That's a nice drop of beer, that. Right, how are we going to do this? I could make up a slide, I suppose. I could try. Let's try. So we only want the two cams, don't we? We want main plus. No, plus OHC. Yeah, I did that in the wrong mode, so you'd have lost the audio and everything there. Right, I'll stay on this camera with audio going while I'm messing about adding the cameras into this one. So we want a video capture device, we want to add the Elmo, and we also want to add in the main camera. No, where's my black magic one then? I need. Decklink video capture? No. Strange, isn't it? So what's my main camera? Black magic device I need. Let's copy that. And we'll paste it. Right, okay. There. Sorry, I messed it. I should have done this earlier, shouldn't I? But you know me. You can't rush a good thing like this. I can't remember the key to. Is it Alt? Yeah, that's better. Just preparing, just preparing. Here we go. We want the microphone in this as well. Right. Okay, let me switch to this one and see if we've still got microphone then. Right. Have we still got microphone? Can you still hear me? You can see me down here, but you can't see me. So we've got our little box there where you can see the twiddling situation. Era appropriate alignment procedure. Let's hope so, Baz. So this is Marconi output power meter. So you set the impedance on these two to whatever you want, and this is the output. Well, this is the scale. So at the moment I'm on 100 milliwatt scale, 10 dB. If I turn it right up, I need to go on the 1 watt scale, but I'm not going to turn it that high. So let's get twiddling. What I wanted to show you first of all, though, I mean, this is the device that we're going to be using for twiddling. Well, you've got like a double vision now, haven't you? But that's the twiddling device. You notice it's got a long, thin blade on it. Well, the reason for that I will show you. We get our other one up. You remember I had a go at doing this. Let's go microscope. Okay, microscope. Come on, microscope. Why are you not working? Why are you not working, microscope? You need deactivating and then activating. Microscope. Why do you not want to work? Hmm. Strange, why would that not come on then? Boop, boop. Yay. It's working now. I know what's going on there. Anyway, let's find me coils. Let's get some zoomage sorted out here a minute. Right, okay. Let's get focus in. So you can see we've got two holes, yeah? Still not brilliantly focused, is it? I don't know if you can see on this one. Can you see a very fine hairline crack there? Can you see that? You would if I zoom in closer. So you can see that that one is actually cracked across, and it's very difficult to see that with the naked eye. Sorry about the shaking, that's my hands. If we look at the other one, no problem. So let's zoom back out again onto the bench. So this is designed to go all the way through these cores. So you put it in there, and then you can turn them easily. Look, yeah. The one that's broken, totally jammed. Now these are hollow. If you just put one of those cheap trimming tools in the top and try and turn it, if it's even slightly snagged, it will break. So if we pop this one out, because this is the open circuit one anyway, you can see what I mean. Because they're hollow, it makes them very fragile. Hopefully we won't break this one taking it out. There you go. So you can see it's a hollow core. So you have to have a tool. I mean, ideally it would have been nicer to fit better there. Well, Aston did make me one. This is made out of what do you call it? It's some phosphor bronze. This is phosphor bronze. So that really is the tool that you need for the job. So if you can get yourself hold of some phosphor bronze, like Aston did. Aston actually made me and a couple other people one of these. So that's phosphor. You see, I've twisted it a little bit there. Obviously got a stuck core, but that one does fit very, very snugly. In fact, better than the old original one. See what I mean? So there you are. Need to bend that back now. I've seen that. So it needs to be phosphor bronze, and that stops it. I mean, it still does affect the circuit. There's another bigger one the other end that Aston put on. So yeah, if you get yourself some phosphor bronze and you can mill it to that sort of size, then you'll have yourself a trimmer tool. Now, why have I bent that? See. Anyway, you get the drift. I'm bending this back now. It is quite a soft metal. Better. Right, let me catch up with chat because the chat is up the screen. You went back to watch the beer explosion. Hey Rob, how you doing, mate? Thank you. Let me catch up. Let me drink this beer while I'm thinking about it. One of those days, Kim. You made it into a short and sent it to me, did you? Thank you, James. Yeah, I'll have to stick that out on YouTube, won't I? The exploding beer. So there you are. That's the insides of one of these. Now that one that's jammed, you can get that out. You'd have to break it to get it out, but you can get it out. I suppose you could glue it back together. It's no different than gluing a ferrite rod back together, is it? I don't suppose, really. But wouldn't recommend it. Right, let's crack on with the alignment then. That was just a deviation. Let's see if we can't get this thing done. So in order to, let's switch back to my new slide that I made up. In order to get to this one, you can't really see it because of the angles, but this ferrite rod here is in the way. this one. You can sort of see it there. That ferrite rod is in the way. I can't get the tool down directly into it. If I can't put it in straight, then again we're going to have a problem with broken cores. So let's just pop this. Ooh. See my scratched up hands now. That I had to rescue well, I had to get to a water pipe in work, and it was growing amongst a load of brambles. So it'll scratch my hand up, you know. There's worse things that can happen to people. Come on. You came off there easily earlier. We don't want to be breaking that, do we? Let's just loosen the other one so I can move it around a bit. I don't know why it's not moving. It's moved easily the other day when I watered it. Right. I should better move that out of the way enough to adjust that now. Right, okay. Fire in the hole then. So you can hear the tone on my signal generator. There's not my signal tracer. Just so we know we've got a tone there. So let's go in and adjust that first one. See if we can make any difference. If I can get it in the hole, no comments. There we go. So we're looking at this meter here now. Let me zoom you in a little bit. We're looking for an improvement. So that one's pretty much peaked anyway. It's going to change when I take it out because it's still affecting the and the second one. Whoa. Third. No difference. These are already trimmed, don't forget. No difference. No difference. So let's turn the volume down a bit and put a bit stronger signal in. Just go over those again. Yeah. That'll do. Right, that's the IF done. So all I'm doing there is I've got my, let's go back to my main camera. All I've got there is I've got my signal generator chucking out 400 hertz tone, 30% AM modulation, and that was 500 microvolts at 470 hertz as per the service manual. Now in the service manual they talk about wobulators and CROs, all the rest of it. Yeah, 400 hertz tone, 400 kilohertz is the IF, and we adjusted cores in the L6, 7 and 8 then. So certainly that second one did need trimming, and it might be because they're all interactive that the previous set needed a different, had a slightly different trim on the upside. So you can detune some and then pull the others up. They're infinitely variable. It's not for the faint-hearted. Stephen, how are you? Dids, how you doing, mate? Can't keep neglecting the bishop. Mick Mac, how are you? Have you a ceramic screwdriver? The problem with them is they're tapered, Joe. They won't go into the cores. So if you use a ceramic screwdriver on these, you're highly likely to break them. If you could get that shape tool, in a ceramic screwdriver, so it's dead straight, like parallel, then you'd be fine if the camera will focus, but you can't. You can file ceramic. I've done it with a diamond sharpening stone before. I've altered the profile of a couple of them slightly. One because I broke the tip off of it, and the other one because I wanted it to fit into a core a little bit better. A visual alignment. Your son-in-law carved you a small screwdriver out of teak. Visit in Wiltshire. I don't think there's any point in taking any medium wave. No, probably not, Stephen. Yeah. I mean, you don't need a lot of power. These should be very easy to turn, a slight resistance. You shouldn't need anything powerful that's likely to snap. I've got my ceramic screwdrivers there, yeah. So this is what Joe is referring to, these sort of thing. Ceramic adjuster. Thank you, Rob. But like I say, they're all tapered. So if you try to push one of those in that core and turn it, you'll just snap it pretty much straight away. But they are very hard material. I mean, you could shape one of these, but these were fairly expensive. So I wouldn't really want to be doing it. Let's just show you what they look like under the microscope. bit closer grain, but yeah, you can see the profile of the tips there. That if I so you can see they are tapered. Is that going to focus? Yeah. So that's a ceramic screwdrivers. These are Draper Expert. I've never seen them again. This is the one that I managed to break. You can see I've managed to reprofile it. But I think width-wise, that one I could potentially file to the right profile. So we're looking for similar width to that, which pretty much is. So that one there could be potentially reprofiled to fit one. You can see the thickness, it'll have to come down quite a bit to match. And then it might just snap clean off then, like Baz says. So, you know, these are useful for some of them, but, you know, unless you've got a very loose core, I wouldn't be putting one of these in really. There's also the these ones, if I can get the top off, or the sort of Phillips ones. So they are useful, but not on these hollow cores. The solid cores they'll work with, but really you want the correct tool. I learnt that the hard way, obviously, by breaking loads myself. I'm not immune to breaking cores. Been doing it for years. It's not a hobby, but you know, I do it. It gets done, doesn't it? They certainly are. Hey Martin, how are you doing, mate? I haven't got my 3D printer sent up, Rob. And how on earth am I going to 3D print that? It's too big. Won't fit in the 3D printer. How do you know you need one, Rob? Is it missing off the photos? So you bought one without a battery holder, have you? Have you bought one without a battery holder, Rob? 3D printing carbon fibre. I suppose, yeah, you could, if you could get the right shape in carbon fibre. I don't know if you can 3D print carbon fibre, can you? It's not the programming of the printer. That's fairly straightforward, Aaron. It's the drawing of the component to start with. You need to be fairly au fait in CAD. You picked up a Philips 800. You used to use a piece of fiberglass PCB with the copper etched off. Oh, I see. Yeah, you could well be right there, Baz. Yeah, I mean, I don't think it's one continuous piece. I think it's just a piece soldered in each end. Not soldered, pushed in each end. I believe that came from Rob Titheridge, who I haven't heard from for ages. Must drop Rob an email. I keep saying that, but I just keep forgetting. Yeah, I'm not sure how Aston did that, but he did do it as a one-off. I think he gave a few of us one of these each as a present. I think Simon had one, and Andrew, Andrew Ausfa. Maybe Paul Cody's, I don't know. start. If I keep bending that, it'll snap off eventually. Right, okay. So that's IF alignment done. Sorted. Right. Let's have a look at the IF. Sorry, the RF alignment. Did I say I've done the RF alignment? I've done the IF alignment. Let's put this back on. I don't know why this is being so awkward. It might be because it's twisted up underneath or something. I don't know. Why is this being such a pain? That's better. We might have to take the ferrite out again in a minute to get at some of the other cores, but we'll see. Right, let's have a look at the instructions. Les, afternoon, how are you, mate? Paddy went to Test of Wisdom Tooth for that. You have to apologise to our Irish viewers now, Aaron. Right, where are we? Here we are. So this is basically what we've just done. Connect output from wobulator. We're not wobbling. And now we're talking here next. I'm surprised it's saying 75 ohm output impedance. Now I have got a signal generator that will do 75 ohms, but it's well over the top, and I don't know it'll go down that low in frequency. That's my beast of a signal generator that sits like a it's a massive, great Hewlett Packard 3336C, and I can get a 75 ohm output off of that, but anybody got any ideas why we would need 75 ohm and not the standard 50 ohms? You know, this is 50 ohm output, I believe. Yeah, 50 ohm. I don't think I can change this one to 75. It's all based around 50 ohms. So yeah, it's we've only got 50 ohm. Screened radiating loop, which you can see is that bit of wire that I got slung over the top at the moment. A shortwave dummy aerial consisting of a 1.5 picofarad capacitor in series with a 75 ohm generator output. A small dust core trimming tool and an insulated screwdriver with a long shaft will be an asset. And then it goes into a big thing about how to make this screened radiating loop. Now if you want to know how to make one of those, Chris, aka All the Gear No Idea, has done a video on making one of those, as has Andrew Alsfa. So if you want to look up their channels, all I've done is made the guts of it. I haven't made anything to hold the coil into, and it's not terminated properly. It's a compromise what I've got, but it does work. So the first one we've got to do is long wave, medium wave, short wave 3. Place a measuring device. Yeah, we got that. Check pointer datum. So this is the thing that we need to do very first. Check pointer datum. And the band spread is in the 0 position. So pointer datum, basically, can you remember last week when we looked? Last week we looked at the pointer and we noticed that when we went all the way to the right, it didn't disappear, but when we went all the way to the left, it disappeared. So it's not central. So that's the very first thing we're going to need to alter. We need to centralize that. And it might be after we've centralized it that we don't need to do anything else, and we can fold the video up and we'll go home early. But I don't think so. I think it's a little bit too far out to be just the pointer, but that certainly is part of the issue. So let's get the main camera back on again and I'll show you what I mean. Let's come down a little bit. So you need to pull the knobs off. There. Only giving us our 2 little felt thingamajiggers. On this, to get the dial plate off, you've got to remove these 4 screws. Is that posi? There's posi drive on this. You can normally tell posi drive screws because they've, well, the old posi drive screws, because they've got little crosses on them as well as the thread. Yeah, they are posi drive. Who'd have known? So we're going to have to take this dial plate on and off a few times before we get this right. But in underneath here, you can see we got our pointer. Now that just runs on the dial cord. So when we're as far over to the right as we can be, let's just see if I can prop this up a little bit so we can see it a little bit better on the camera for you. That's better. Right, so if we put the dial plate back on now, I'll show you what I mean. So you can see here, you can still see the pointer. Look, can you see what I mean? So if I turn it that way all the way, you can still see it in the window, yeah? So if I go the other way, oh, that's me pushing too hard on the dial. If I go the other way, as it comes to the end here, just keep an eye on it. It's gone. So that means it's too far that way on that dial cord. So we need to move it a fraction so as it just appears there and just disappears there, if you know what I mean. If you know what I mean. So you just get hold of it with a pair of pliers preferably. Hold the pulley. I'm just going to slide it along the dial cord a fraction. So now where are we? Well, we still can't see it. It needs to come a bit further, a bit more further along. Well, I can just see it peeking through there. It's gone a bit skew-iff now because it don't like being twisted on the cord. If we put it back the other way. it's a bit it's a bit, well, it's standing to attention, isn't it? Let's just turn that off. I won't short anything out here. That's because of the way it's twisted on the dial cord. If we move it up and down a few times, holding it down, it probably sort itself out. Nope. Come on. Don't want to. That's a bit better. Right, let's just pop that dial plate on again. So let's see where we are. Okay, so it needs to be around about there. Let's just mark that. It needs to be there. So if I do it all the way, so it's got to come that way, around about. So it's about 3 mil. It's got to come across. Just grab out of that dial cord. I'll put the pliers down. Stuff's dropping on the floor. That's pretty much there, so let's just try that. So I can just see it peeping just on the edge there. Let's just try that across the other way. So that's a bit too much pressure on the dial plate again. Okay, if anything it wants to go a fraction that way. So let's put it back there. It wants to go a very fraction to the right hand side. Yeah, I can see there it wants to just go a little tiny bit. Try that. It's still too far that way. Got to come a little bit more. A little bit more to the right. It might be that I'm just pulling the spring each time I'm doing this and it's not. Yeah, it is doing it. It's gone all. That's still too far. What's going on with this thing? Let's try that. It wants to be about there. We'll get here in a minute, but this is quite important because it'll save us a lot of messing about later. So it wants to be there. What? Cool, so that's miles out. Do it a little bit at a time because it might be that it's no, it's got to come out further than that. Yeah, I think the problem is this is spring loaded, so it ain't moving. It's pointy upwards. Don't worry about that, by the way, because it's got a little bit here that rides along the plastic on the top. So I need to jam that pulley there and pull this along like that. Come on, be there now. Well, how many goes we're going to have a go at this before it's right? Yay! No. That's pretty close though, to be fair. That's pretty close. Just disappearing like that side. It wants to probably just come a fraction that way, but I think we're not going to gain much by keep messing with it. Apart from maybe get it to not quite sit quite as upright as that. Come on. You need about 15 hands for this, as you can see. Do this about 500 times and it should be good. Jim, how are you doing, mate? Still too far that way. Still too far that way. Not quite so erect now, but you know, I've gone and said it now. It was a fair way out before, to be fair, so it seems to alter every time I move it, you know? I'm not sure what's going on with it. It seems to just go back to where it started. That's definitely moved that time. I've gone too far now, I think. Too far. The problem is it's sort of spring loaded, so every time you're adjusting it, and maybe sliding the dial cord along the pulleys as well as the marker. I think that's good enough now. I mean, it's just peeping now, that. It's just peeping. It's beep, 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 beep. That'll do me. I've done enough messing with that now. It's too long messing. Certainly is more central than it was. Gavin, how you doing, mate? Christoph's in as well. Alright, let's put our little thingies back on. Oh, hang on, that's the wrong one. One's got to go on there. One of these has got a pointer on, one hasn't, so. Right. I'm happy now that we've got our pointer in the right place. So I better have another sip of beer. Jerry, how you doing, mate? Shane, how are you doing, mate? Just out of view on both ends of the scale. That's how it should be. Should just about pop out of view. I think this one does now. Let's just double check. Yes. So it's pretty much, you can't see it there now on the left, look. Just see it peeping, look. Just out of view. And on the other side. Coming up, coming up, coming up, coming up, coming up. Just out of view. So there we are. It is central now. Which is good, because we'll be here another 5 hours. I was trying to adjust that. Let's have a look at the alignment then. Let's go back to the instructions now that we've got that first bit done. So we've got to make sure that the band spread trim is in the 0 position, and that is this one here. Where is it? Here. It needs to be dead upright. In the upright position. Which it is. And we now got the pointer datum correct. So let's stick you over to the instructions here. Fix L4 main winding to the center of the rod. So what it's saying is to move the ferrite rod windings. These are fixed in place. Yeah, I don't mess with that unless it is been messed with before, if you know what I mean. If someone's had that apart and started sliding them up and down, or the glues come loose, or they're moving too easily, then yeah, definitely do that. But you know, these are all wired together, they don't really move much, so I'm not going to do that bit. I'm not going to move L4 and L3. So is it wanting this 400 hertz again? Yeah, so it wants 400 hertz. I like that. It's not quite so high pitched, is it, as the 1 kilohertz. So we've got our screened radiating loop. What is it asking us to do here? Three turns. Oh, that's yeah, okay. Switch to medium wave. Inject 600 hertz signal. Set the pointer to 500 meters. Right, okay. So we've got to set it to 500. We've got to set the signal generator. 600 kilohertz. Adjust L1 for maximum output. Right, let's get back on to the offending item. Actually, let's prop it up a little bit so you can see. Right, let's zoom you in. So we're set to medium wave anyway. It's asking us to set the pointer to 500 meters, which is just here. Now you can probably see whether that's lined up better than I can. Let me just stick my great Swede in the way. Right, let's bang on 500 meters. And adjust L1 for maximum output. Right, let me see if I can find L1. We need to find L1. do that using this book here, so keep going forward and back all the time. L1, all these adjustments are pretty much on the switch panel, I think. Yeah, so L1 is this coil down here, which, if I turn it that way round, it is smack bang underneath the ferrite again. Okay, let's turn it on and see where we are. Wow. Maybe slightly off. Not much. Let's link that back a couple goes. Turn that up. Make sure we can hear that still. A lot of interference, as is always the case. You want to see the output meter. Where is he? Where is he? Here he is. Let's switch to my other view so you can see where we're going. So the bit that we're adjusting this time, just adjust this one in a bit. Is that little coil in there? That one down there. And we'll just turn this up a fraction so I can hear it. Can I get this in? Don't think these are hollow now. Can't even see it. Let me get my light in. No, these are not hollow now, so we can go to a normal trimmer, which I believe is that one. There we go then. How about that? Better. Okay, what next then? Gained a bit on that, didn't we? So next up we've got to inject 1400. Set the pointer to, so what is 1400 kilohertz in meters? It doesn't tell us, does it? That's a bit naughty, isn't it? What's 1400 kilohertz in meters? That is really naughty of a minute. Okay, it actually does show us. It's going to be, because we've got megahertz on the scale. Alright, so we can see that. That's over here. So let me just dial in 1.4 megahertz, which is what it is. That wasn't far out at all, was it? So it was mainly the dial pointer was out. Right, 1.4 megs, that's where it's sat now. So I've got to go to 1.4 megahertz. I can just about hear that. I'll catch up with the chat in a second. Let's go to... So you can just about hear that if I tune around. It's a fraction off. It's literally next to nothing. It's almost not worth changing. It's almost not worth altering. So what have we got to alter for that then? TC2 next. We need to find TC2. So it's going to be one of those little trimmers, which are a pain in the neck to get at. In the back. So TC2 is in between long wave and medium wave. And it's the lower one. Okay, let me see if I can get you in there a minute. Let me see if I can get you in there a minute. Bit tricky to see this one. Where are we going with this, Graham? Can you see that? Well, it's difficult to get any light or anything in there. But it's that one down there. I need to approach it from a different angle, really. I need to come up here and then turn that one sort of that way, really. And now that's in the way. Is that it there? It's that one there that I'm trying to get to. Yeah, you can see it. It's that one there. Right. Let's get a suitable screwdriver. Well, that's strange. We've got noise and not the signal is showing up better, but you can clearly hear that we now have the signal. If I move, bro, right, okay. $214 meters. So that's a bit deceiving, isn't it? Because you can clearly hear the tone there, but by increasing the noise increases the Yeah, you'd probably be better to look at that with an oscilloscope, to be fair. You would see it better with an oscilloscope. 214. We're all around 214 meters, but a test set can take external modulation. It can do, Baz, yeah. It's modulated. It is. It confused me there, Aaron. So if we look down at the set again, come across to where we are. I don't know how much in line you are, but that's our 1.4 megs there. Look. So if I tune either side of that, it's not perfectly lined up with you, but it's got to be there, isn't it? Bang on. Right, okay. That's that bit done. What does it want to do now? Right, now it wants to mess about with the Far-out roll. We're not touching that. We're not touching that. Now it says to... Let's just take you on there. Now it's saying to switch to long wave. Set the pointer to BBC 2. Well, we know radio 4 is on 1500 now, which is actually 198, which is pretty close. So we've got to set it to there and then adjust TC1 for maximum. So let's go there first. So radio 4, as it was the BBC Light station, it's actually marked on there just for us. So you need to switch to long wave. Then we need to come across to the BBC 2 light position, which is just there. Get me great head out of the way. Again, it's slightly off for you because the radio's not flush in line with the camera. Which way's it got to go? It's got to go that way, isn't it? Oh. So that's where we need to be. So that needs to have
Wait. She brushed herself against him and those two danced quite carefully that night. It was all anyone talked of. The room seemed to empty, so that it was just the parents.
So we don't need to really worry about
Jolted their bodies and all the candles were blown out by the hurricane they whipped up. All brown bones didn't sit in the corner.
we don't need to worry too much about looking at the thing now, because we're listening to audio. If you look at audio, like speech on one of these meters, it's all over the shop. So we're listening for the best reception really for that station. And we've got to find TC1, which is in a different position again. TC1 is back here more. Can you see in there? No, we're looking at the blue, so we're over a bit from that. The problem is the light's affecting it as well. So we're altering this one here. turn that off a minute.
Sorry about that. Last orders, I'm afraid.
Oh, do you have no food?
Another time.
I cannot have half the story.
I'm sure you will survive.
Life. Traveled across a whole ocean. I left my family behind.
That's best there.
Collecting these stories and you cannot even be bothered. Finish.
Well, perhaps abandoning your family wasn't such a good idea.
Unfortunately, the light effects that you see.
Mr. Knickerbocker, you are drunk. And if you raise your voice from
And if that one.
that man in the corner, he will very happily pick you up, throw you out, and break your arm in the process.
So I believe that one there is the one that we were altering for there.
All I will say is that Ichabod left the party early. I do not know.
That's the one we were altering there. That.
Told you what happened?
No one ever spoke.
Sorry about the light, but that's about the best I can get at.
He disappeared. Gone. The rumor I heard was that the Headless Horseman got it.
H. Neil, how are you, mate?
It's what they
Of course it is.
don't understand.
I need to clear up Mr. Knickerbocker, and you need to leave.
Can you just explain?
I said you need to leave.
What about this headless horseman?
All I know is that because...
So we've got that. What's it want us to do now? So now it wants us to inject 174 kilohertz. Inject 174 kilohertz. 0.174. It's right on the limit of this this signal generator, but it will do it. It's not that accurate down low, but it will do it. And we've got to adjust it to. We've got to adjust it to 1718 meters. So again, we haven't actually physically got a 1718. I mean, it doesn't go there, does it? I mean, I can see 1700 there, but there's no. Actually, there is a little dot. There is a little dot. Okay. There is a little dot. Can you see that? There's a little tiny dot on top of the dial. That would give us our little marker, wouldn't it? That's quite nice of him to do that, isn't it? Right, 1718. So, can we hear that? No, we can't. Where's that to then? Let's go, let's pump it up a one. And maybe my signal generator isn't. Nowhere to be seen. I wonder if it's my signal generator is not managing to do it. Let's try 10 millivolts. Should be over this side more now, really.
You mean Katrina?
What are we supposed to be adjusting then for this? So 1718. Ah, adjust the long wave coil. Right. Well, being that we can't hear it anyway for some reason, I'm not sure why that is. I'd be more inclined to think that my signal generator won't go down that low, and I can't plug my other one in. Yeah, I can't plug my other one in. Let me just take the tape off of this and see if I can get it to do it, but I don't think I'm gonna. So I'm just taking the tape off of the aerial coils here at the moment. Where are we? Yeah, I'm just taking the tape off of the long wave aerial coil just to see if moving it will pull that signal in, but I don't think it will. The problem is these wires are held by all of the tape. So you've got to unwrap all of the tape to move these. I don't like messing with these aerial coils, to be fair. Being we've only got one station on long wave, which is the one that we've got dead accurate on the scale, this is a bit unnecessary, but let's just see if we can pull it in. I think it could be more of an issue with my signal generator. And the wires are trapped by the coil, by the clamp as well. Still nothing. I'd be inclined to think my signal generator won't go down that low, but I wonder if it's possible to get the other one going. Let me just see if I can find the lead a minute. Talk amongst yourselves. Talk amongst yourselves. Sounds like the local oscillator is dying. Yeah, it is quieter up that end. 175 megahertz. No, I haven't. I've got 0.174 megahertz. 0.174 Bass. I'm not that mad. Shane can hear Caroline in West Berks. Ricardo, how are you, mate? I don't think I said hello. listen to the output, can't I? Why can't I get that then? See if I can get it on another radio. That would tell me, wouldn't it? If it's the radio. Ah, low battery on that one. Chris's hasn't got long wave on it. What about the good old batteries in these? None in that one. What were we looking at? 174. I think the batteries are gone. Yeah, I'm not surprised. We've got a bit of a mix of batteries in there. Get them out before they start going bad. Oh, look at that. We got a Duracell leaked in my radio. No. Damn Duracell. God. You little. Got a Duracell leaked in this one, look. You see that? So 4 batteries in there, and one of them's a Duracell. I shouldn't have mixed them really, but I think I was panicking to test something one day and decided that I was going to do that, and never a good thing to do, is it? Mix and match batteries. My own fault. Told Rob off for that before. Let's put. I just want to see if this signal generator is outputting that 174 kilohertz. Yeah. These are rechargeables. I'm not sure the state of these because I haven't had the charger plugged in, but hopefully they'll work. Yeah, it's working, as you can hear. So this radio is not receiving on the left hand side of the band on long wave. Interesting. Why is that? Why is that? Let me just check the. It might be that it's been detuned. It's been twiddledy-deed by somebody. So let's have a quick look at the trimming for the other side of that. So inject fire loop 260. Set the pointer to 1154 and adjust TC3. So if someone's really messed with TC3, that would do it, wouldn't it? So let's get back down on here. So it says to 1154. So is there a mark on there? 1154 meters.
Has a husband.
I mean before.
I don't know where that is. There's no mark this time. Unless it's there. Let's try it. That's the wrong end of the thing though, isn't it? It seems an ass about face way of doing it really, because we're adjusting for BBC in the middle of the scale pretty much, and then we're doing the right hand scale with the coil and then the left hand scale with another trimmer. Doesn't seem right. Okay, let's pop in that. Let's turn that noise down a minute. So we need 260. Well, that's bang on. Well, it's all over the place there. And there's no indication on here at all as to where that should be. No indication at all. That's strange. And let me just see if it says anything different in the hacker book. But that looks to me like it's exactly the same text. Right, okay. L2. Set the pointer to 1154 meters. Well, where is 1154 meters? I would have thought it'd be more over here, but and then we're adjusting TC3. Let's find TC3 a minute. What screen are you on? Oh, you're with me on this one, okay. Throw moment. No worries, Baz, what are you saying there? Check a local oscillator with a scope. Thrown. Sheffield Steve, how you doing, mate? I do remember listening to Radio Luxembourg. Definitely, we used to have it on the car. Adjust dial to non-existent dial position. Yeah, exactly, Baz. It's that does seem strange, doesn't it? That there's no dot. I mean, there's dots over here that indicate, maybe indicate positions for trimming. Or maybe, oh no, I don't think it does. So that's 1200 there. 1200 meters, but we're looking for 1156. Well, I would have thought that would be more back here. 1156. I would have thought it would be more back this way. I was just going to adjust TC3, see if it livens up the other end. Let's have a look. TC3, where's TC3 then? I keep folding that page in. TC3 is the top one up there. Let's just adjust that one. Because it's hellish sensitive on this. Of course, the light's playing up again. It's a hell of a wide bandwidth. See if that's affected BBC Two. See, that's not altered that at all. Radio 2, you can't see, because my aid's in the way. So BBC 2's still bang on. So I come up here now. Let's try that other one again. So what would 1800 meters be? What's 1800 meters then in megahertz? Let's just find that out in a minute. I have got a chart here somewhere, but I can't find it. .167 apparently. 167 kilohertz is 1800. So if I align that to 18, which is a known one, let's try. Nothing on the lower end of long wave for some reason. There is there is a capacitor in there that I should have changed, but that wouldn't have pulled it down, would it? But surely the oscillator could be dying. There's definitely nothing there. I mean, let's max it out. Let's go amplitude 100. Ah, hang on, that's null in it. Okay, so it can hear it maxed out. So you can hear it there. It's almost like we can't have a problem with the coil because it wouldn't work at all. It's picking it up mega quiet. There. But that's 100 millivolts. That's like a massive signal. The neighbours are hearing that on their tellies, I expect. Doesn't seem right, does it, for some reason? Can you hear that now? And I've made that better by adjusting the aerial coil up the top here on the other side of the set. So that's my coil on the aerial coil. See, it gets worse there. Better. And it starts getting worse again. But that should be absolutely blasting in at that. I could force it through, but let's get some tape and just take that a minute. What I think of it. So that's a component gone out of spec in the long wave circuit potentially. Let me just do that again to make sure that hasn't moved because it's captured by those wires there. Huh? Gone? Ah, yeah, wire's come off. It's there. That is Bazov Catch you soon, Baz. See, 1 millivolts, it can't even hear it, so there's definitely something amiss there. Do we need to even bother trying to search for that, though? What could it be? How you doing, Anthony? Let's have another look at this a minute then. So, this is our oscillator circuit. Well, obviously we are working in this area. This is okay because we can get medium wave, no problem. So this part of the circuit, which is the same for medium wave and long wave, is fine. It's where we come down here and we're specific to long wave. So it could be that we've got a problem with C5. I'm just trying to think what else could be wrong. Well, they are connected, aren't they? I mean, to find that fault, you'd have to probably go through this whole half of the board and maybe even look at the switching, but the switching should be okay because it is switching across the long wave. Yeah. I mean, it could be that transistor's not doing the lower frequencies very well. You know, TR1, it might not be able to cope with that lower frequency. A BF194, I don't know. Could be. You know, it might be some of these components are passing the higher frequencies of medium wave but not letting long wave through. You know, one thing we have got is this capacitor here. Now, I believe it's that one, C3. Yeah, so C3 is still the existing old Philips capacitor. And that is definitely in that circuit. It's coming off the switching. Is it touching any of the... No, I don't think that could cause it. There's a long wave, medium wave, switching then. This one here is a long wave. It's aerial coil. Could be a dodgy aerial coil. It could be that the trimmer's dodgy. Up here even. What's your thoughts on that then? Thanks, Rob. Ernest, how you doing, mate? Thanks for dropping in. I didn't see you there. Hope the old radio's still going strong. John, how you doing, mate? Didn't I say that a transistor was dying at the end of the last video? I don't know, John, and welcome in, mate. Tim's saying that voltage drops. Well, you know, obviously we're on a power supply there, but yeah. Let's have a little nose about then. So we need to get that capacitor out of there. Have I got another BF194 we could try? That's a good question. Have we got another BF194? BF9194. According to this, we've got 2 in box number 3. Anybody got an equivalent for a BF194? Save using a lock fit. Both of these look like pulls actually. Well, that one might not be. That one's a new one. Okay, so we have got a new old stock BF194 we could try. BF39. I'm just looking at Mark Hennessy's page here. I don't know if any of you are aware of this. That if I pop that in the chat for you, you can have a look at this document yourself while I go to the loo. Because in there he's got some very, very useful information on transistors and equivalents. So I'm just trying to see what equivalents he's recommending for the BF194. So he's saying 494 or 394. So yeah, right, I'm going to the loo, won't be a sec. Right. Okay. How we doing? Catch you soon, Derek. How many milliamps a cassette motor pulls? Yeah, the problem is it's an oscillator, Aaron. You've got to be very careful messing about with RF transistors in an oscillator. I have looked into commands, and there is a possibility that I can set some commands up that we can use. Now I've actually gone and pulled one of these out of the fridge. Course, because I'm still on my low carb diet, and it is low carb, apparently lower carb. Hopefully this won't spray everywhere, but I didn't get any finger this week. Forgot all about the finger. Sorry, dudes. So we're going in with the cores. It used to be called Cores Light, but it's no longer called Cores Light, it's just Cores now. Cheers everybody. Round 2. Tom and Susie off. Catch you soon. And Mary. Forgot Mary. Apologies. Yeah, that's what if you look at that thing I'm sending through, it's brewed just down the road from you, Joe, is it? Wow. So if you look through that document, it's giving you 394, 395. Well, sorry, 394, because you want a 394 for a 194. And a 395 for a 195. So let me see if I've got a 394. Which I haven't. Ah, where did that go? Oh, that's because I was opened it twice now. Right, what was the other one it suggested? 494, 394, or 184. I got 184. I got loads of those. I got loads of 184s. So what's it say about 184s? So I'm looking at this here now. BF 184 I've got loads of. Got a 4th lead for screening. There's actually quite a few here. So BF199. I'm looking at my electronics stock list here. Look, so I've got BF199s as well. You can see I've got 2 194s. I got a 494B. Did they say 494? Oh, am I just cracking up? Oh, I've got loads of those. There might be a different pinout though. I think I'll stick with the 194 because I know I've only got 2 of those, but they are lock fits, which is not really great to fit lock fits in there really. I'd probably be better off putting one of those 494s in. I don't know what the bead denotes, that's probably the gain of it. Anyway, I haven't, Martin. Oh, hang on, my camera's frozen. Look a bit crazy there, don't I? That's better. Dear, oh dear, that wasn't a good look. No, I haven't sorted them, Martin. No, you didn't send me any lock fits, did you? Do you send me any lock fits? I have got some lock fits somewhere. Now, where did I put those? It doesn't matter anyway, because I have one here. Look, I have a new old stock BF194. This is a Siemens one as well, not ever been used. But what we'll do is we'll try the let's just go on to the main camera. I'm going to take this. This is the only capacitor that we haven't done so far, so that one's going to come out. The other one that was just in that circuit, if I can find the circuit diagram, was C5, which is a 380 picofarad. Worth taking C5 out for a nose. Worth taking C5 out for a try. C5 is a little tiny thin. There's probably a mica sandwiched in there. So it'd be worth taking that one out to have a look. Because that one's paralleled up with one of the trimmers for medium wave. Long wave even. Right. I'm going to take this offending article down here out of the way. So what have we got? This is the negative here, that big pad. That's easy enough to suss out. I was doing all the caps anyway, just that one was the only one left in the set, I think. Oh. When that coming out then? It's not held in by anything. Maybe it's a little bit blobby on the end of that leg, or it bent a little bit. Well, it's bent. Can't get hold of anything because these ferrite rods are in the way of everything. Literally, they're in the way of everything. Get my fingers in there because the ferrite rods are in the way. Yeah, and that's got a little bent over bit on the end of it. Just snip that off, it'll come out easy. Strange, it's an 80 microfarad, that one. So we'll see what that one looks like on the tester. So if you want to get your thinking heads on, I'll just drop one of my leads. For 80 microfarads, we'll get it on the ESR meter. You ever think about that one while I grab an 82? Is it? It's a weird and wonderful size, isn't it? I think that in my stock here, the 82s. 8.2, 8.2. Maybe they're not. So they tip that lot out, then that would make me cry if I tipped all them out. Must be in here. Yes, they are. You could probably get away with sticking 100 in there. You don't have to stick an 82 in, but whether it would affect the sound, I wouldn't have thought so. I think it's just like a, almost looks like some sort of damper for the switching, maybe. I don't know. Anyway, I'm going to stick it in. So negative is there, so it's that way around. Still can't get my fingers in because these damn ferrites. It's a double ferrite situation going on in here as well. A double ferrite. Let's get them soldered up. Not even got the soldering iron turned on. We weren't doing any soldering today, like wasn't thinking of doing it. So far all we've managed to do is the medium wave alignment, which may have changed now I've done this capacitor. I don't think so, but you never know. And the IF alignment. So we've done some things, not a lot. Actually, I have to put a bit of this. Now the likelihood of me having one of those picofarad capacitors is highly unlikely. What was it? 380 picofarad. Is that even a normal size? 330 picofarad. 470 picofarad. 220. Now, capacitors, is it in parallel that you add them together? Can we achieve that by adding a couple together? It's more likely going to be a mica, isn't it? There's no point me pulling that out if I've got nothing to put back in there. It's going to be a mica in the low frequency RF stage. Gotta be, in it. $560. I've forgotten what it is now. I've even forgotten what it was now. Right, should we do this capacitor while we're faffing about? Are we all at a guess? I must get my 3D printer set up at some stage. Here we go then. Have we where to go? It's in parallel, is it, Anthony? See, it's not gone hardly high at all. 92, there's nothing wrong with that one. We were changing it anyway, so it's not a problem, but that's not our issue. That is not our issue. So, if I can't find another one of these, I'm going to, well, we want to test it first, changing that cap, but that's not going to make any difference. I'm not even going to bother testing it, changing that. .380 picofarads. Is that an unusual size or not? I don't know. I've got quite a few mica ones here for various things. 47, 380 is what I need. 18, 47s, hundreds, 56, 560. Ooh. Getting close. 600. Right, now I've got all of these old. Look at these. New old stock from millions of years ago. Now, is that going to be quite a lumpy one? It is, isn't it? It's going to be one of the bigger ones. 35, 100, 270. Okay. 270. What's that one there? The refreshment wine 380 I'm looking for. 1. $60, I think. 150. Is it 160? Yeah, 160, I think. 160. 25. Well, it could be here for hours trying to find one of these. 25. 100. God knows what. 250. Shall we pop it out and see what it's reading first, or shall we just change this one? Shall we just change TR1 and see what happens? Even in 574 RZ 460V3. These are mica, Richard. 330 plus 47's close. Stars above. Stars above. Oh, that's good. Yeah, I like that. Stars above. I'll never remember it though, stars above. Cheers, Peter. So who got closest to the capacitor then? $92, wasn't it? Let's make sure that is definitely TR1 that I'm looking at. Yes, it is. Let's pop that capacitor out just to have a double check that it's not that that's causing us our issue. I'll find where it is. It's there. I'm trying to work out where the hell it is. There to there, maybe? Oh, steady. I think that's it. Oh, he's hot, so it must be. Oh. Again, I can't get my fingers in there, it's too far away. Oh, that's strange. It's a 68 picofarad. What? Now I'm confused. .68 picofarad plus or minus 5%. Have I got the right capacitor? C5 according to that. Hang on. Yeah, that's the wrong one. Wrong capacitor. That's not C5. That ain't C5, Graham. What do you take that out for? That's not C5, that's C23, boy. That's C23. Wait, on the circuit it says that's 90 picofarad. Well, oh, hacker, what are you doing to me? I'd done that all to myself, actually. That was nothing to do with hacker. I'd done that. I just took that out for the sheer hell of it because I fancied taking a capacitor out of circuit, so I thought that's the one. Ah, dear. Let's just put that back in circuit a minute. Get my finger on it to hold it while I bend the legs back over. Okay, let me have some more cores. Where the hell is C5 then? C5 is in behind that oscillator cam. Whoa, that's tricky. I can only see one leg of it. Just there. Is the other one here? Yes, it is. Well, I'm going to struggle to get that in again. Can't get anything anywhere because of these ferrite rods. They're a nightmare. Can I push that one through that way a bit? No. Push it through that way a bit. Yeah, get out of the way, little swine. Right. There he is. Lemco 360 picofarads, exactly the same as my Lemco ones here. So let's test it. It doesn't look particularly good. Let me show you. I think it is. It's just, yeah, it's just the way it's made, I think. There, ooh, steady. Yeah, the legs sort of join up here. 360 picofarads, 2%. Shall we see what it measures? Let's get the LCR out. So for some reason the bottom end of that capacitance range is not playing ball. I'm just going to do the probe compensation on this a minute, so as we know where we are. Short the probes and then press enter. What have you destroyed? You just finished short circuiting the CD mech from an 80s Technics CD player. You short circuited it, did you? Martin Graham? What's that? Right, open the probes. Right, let's get that capacitor in here then and see what it measures. So it should be 360 picofarads, thereabouts, plus or minus 2%. Look at that. That's pretty accurate, isn't it? There ain't nothing wrong with that one. There is nothing wrong with that. So there isn't much else to try apart from maybe switching out that where's my big tweezers, big tweezers. Yeah, apart from switching out that transistor, there's not really much more in that circuit we can mess with, apart from the aerial coil, of course. But then that can't be too bad, because we have got radio. We have got radio 4 on long wave, so we can't have an open circuit coil. It could be a combination of a few things. We could have some sort of mismatch, I suppose, but Normally it's component selection. So all we've done really at the moment is just change one capacitor. So the only other thing I'm going to do is whip this transistor out, and I'm going to try a new transistor to see if it performs any differently. Come on. You're out. You're just playing hard to get, aren't you? Before we solder the new one in, we'll just check what I've done with the other one now. We'll check the differences on the component tester just to see if there is any differences. I wonder if we could have used the curve bug to test them. Right, let's test the existing one first then. The old one that I've just taken out. See what this measures. Okay, HFE is 118. Doesn't give us any frequency stuff on this. All it's given us is an HFE really. I see it's a collector current, I believe. The voltage between base and emitter 0.823. Okay. Doesn't mean a lot to me, to be fair. Let's test this one. Test it even. So although these are both good transistors, they can alter a little bit. See, that's a much lower HFE. HFE of 60. Let's chuck it in though. I'm sure that's still within range. Well, actually, shall I? No, because the other one's a pull. The other one's not no stock. It's just been pulled from another set. I don't really want to risk that. And we are messing about with something that's not really needed to be fixed here, because we've got nothing in this country apart from Radio 4, which we're receiving perfectly well on the correct frequency. What's going on here? Do I even solder? What am I doing here? Let's just use this. BNC here. Why aren't you soldering then? Is it because you don't like the thin solder? Thicker stuff for you? Is that what you need? I'm talking to the transistor now, look. There's not much hope left for me now. Better. Right. Let's see if swapping out the transistor did any difference. Did us any favours? I don't really know many of the other bits in there that would affect it. Obviously the padder capacitors, of which I don't think I've got any. Anybody know of a decent stock of padder capacitors, then let me know. There must be someone that's got loads of the things knocking about. Okay, so where are we then? Let's have a look here. Are we all connected up? That's connected. That's connected. Let's go far in the hole. Put that on. Don't need that on for a minute. Okay. Aerial coil. What are we on? 167. No. Can't find it at all now. The local oscillator definitely dies, so we get to... Radio 2's not coming through now. All this stuff here, is it? Let's try that again. Okay, so radio 2 has now died. We have got our ferrite hanging in mid-air though, but that's definitely... Well, that's worse than before. That's actually worse than before. No, Rob, we've discussed that. You're the only one that entered, Bob. That's strange, because now we haven't got radio 4. Is this because it's so far out of tune now that we've cured it with replacing that transistor. We might need to realign it. Let's have a quick look. Let's turn the output from that off for a second. So just TC1 for maximum. So we'll find TC1 again. Let's see if we can find radio 4. We don't want to lose radio 4 because that's the only station we've got. We do not want to lose that. TC1 is the big one down there. Strange. Seems like we've lost more of it now. Seems like we've lost more of it because we're dying. This is weird. Let's chuck in 2 kilohertz. Oh, sorry. 200 kilohertz, which should be around radio 4. Let's see if it'll pick that up. That's bombing in. Just died again. Dying lower down now. And me adding a frequency in is pulling it back in again. Maybe our transistor that we put in isn't great. We've certainly affected it by changing the transistor. I mean, that's the only thing we've changed. You know, I've taken that aerial out there, but that's not affecting it, unless it's detuning it, I suppose. Could try pushing that back in. How strange. Well, we got an oscillator coil on this aerial as well. You blame me for making electronics repair easy. What's worth checking? Oh yeah, the cap. Yeah, it could be. I mean, I'm back to square one with the... Hang on, which... not enough operating frequency on the new transistor. Yeah. Are we in the realms of... There's got to be something else. Got to be something else. Because now we've gone the other way and I can't really pull radio 2 in now. It does seem like a capacitance thing, you know, but let's try, we could try the BF494B in box 8, of which I got 44. That's a different transistor altogether. Where are we? It's moving.
President Manuel Cater's policy would give Lottie's family and many others a life. After auctioning off their possessions, Lottie, her brother and parents...
One thing is worth checking is the voltages around the oscillator. Because that... we have got those nasty old resistors in there. Let's have a look at the schematic a minute. Let's have a combined look at the schematic again. So this is our medium wave, long wave oscillator. No point messing with the oscillator core because that's the same for medium wave and long wave. We know medium wave is okay. The transistor could certainly affect the frequencies. You know, we've got a couple resistors here that could, I mean, that's the ground. Where's it getting its power from? It's ground. Switching. Yeah, it's going to be switching the power through these, isn't it, I suppose. Hang on, we got L3, which is to do with long wave as well. And we got C23. Well, we pulled C23, but I mean that's 68. Did we? Was it C23 we pulled? It was, wasn't it? Yeah, it was C23 I pulled, and that's actually 68 picofarads. According to that, it should be 90. But then you should be able to adjust it with that one in parallel, unless TC3's knackered. But it's all sort of coils. I mean, could L3 be a problem? Could we have an issue on L3? Maybe there's something wrong with that. It's confusing because there's actually 4 coils. There's 4 coils on the antenna. It might be worth resoldering those in case one of the joints is a bit dry inside. So definitely C23 is not as per the schematic, but that's nothing new, is it, with manufacturers changing stuff. Got some amendments here for other stuff. Let's have a look at the diagram here for the later model. No, C23 is still shown as a 90 picofarad. And there's no amendments I can see to say they've used a different value. So have we got maybe the wrong capacitor in C23? Is that just a coincidence I pulled that out? I mean, it looked original enough to me, but I don't know. I'm just wittering for a minute. I can't see the chat for a second, so bear with me. I'm just trying to see if I can find what is likely to be an issue. I mean, we've certainly got to check this coil, but what can you check? I mean, it's either open, it's got to be working, otherwise it wouldn't. Yeah. indicates components on the main chassis. So this point here is on the main chassis. That's just a connector for some reason. Or is that an external aerial? Ah, yeah, aerial socket. Ah, so that pickup there is just for the aerial then. So we can ignore that. So this is the aerial trimmer, TC3. I think we've messed with TC3, haven't we, as part of the alignment. Yeah, TC3 is the other end of the scale. We know that we can achieve that. C23 being 90 is a bit strange on there, but like I say, you just never know. It's not a million miles out from 68, is it really? And you should be able to pull that in with that trimmer. You know, I mean, somewhere here we've got voltages, amplifier, what, TR1, wasn't it? So receiver switch to medium wave, TR1 should have 9.2 on the collector, 3.2 and 2.65. So we can check that. Let's check that. I don't know how these are laid out, but we'll get a feel for it. So 9.2, switch to medium wave, which is fine. This is proving to be a real pain in the backside, isn't it? So I can't remember the pinout on these now, but I'm sure we'll work it out. In fact, we can go over here because we've got a nice big ground over here. Let's go in there. .3, that's obviously the collector. 2.4. We got one that should be 2.6. To be fair, that's pretty good. I mean, that should be 3.2. It's 3.16. That should be 2.6, it's 2.5. And our collector's 9.3 and it's 9.3. So there's no problem with the voltages on that. Right, let me just check the differences on these two components then. I think the pinout's different on these two. I wouldn't have thought so, Rob. It looks like the original transistor. I mean, it didn't look like it had been resoldered. There's loads of muck on the board, but... Right, let me just check the pinouts of these two then, because they are potentially different. We get a bit of scrap paper. loads of scrap paper here somewhere that I had nicely put to one side for just such a situation. And I thought I had a pen out, which I did, but it's gone. Let me just have a look at these then. So that one facing forward. Then this one facing forward. And just so see the pinouts. Right, red is the base, so base is the right hand one. Green is the emitter, and blue is the collector, so CEB for that one. Let's try this one. That's a better gain, 142. So let's have a look here. Blue is the left hand one. So blue is the collector. Red is the emitter. And green is the base. Well, they're the same then. I thought they were different. Okay. Okay. According to that, they're the same. So let's pull that out. Invincible Violinist, how you doing, mate? Yeah, I agree with you, Invincible. John Turner, could shortwave 1 longwave switch be dirty? Yeah, it could be, but it's working partially, John, which is the thing. So it's switched across, and punching the switch doesn't make any difference. So I'll give it a squirt of deoxit and let it sit in there a minute, by all means, while it's festering. We can give it a little squirt of the old deoxit while it's festering a minute. If I can find it. And there it is. Where's my tube? There it is. Yeah, I think I squirted all the switches last week, didn't I? Let that have a little drink while we're certainly changing that transistor has changed the radio. I'm waiting for that to heat back up now. Let's put some of these things out of the way for a minute. It's really strange that we have got nothing on the top end of that radio for long wave. Very strange. Chucking stuff around. pretty sure I've done all the switches in this, but no harm in doing them again. It won't hurt them. Because they all interact as well, of course. It might be the radio's never ever been used on long wave. It's unusual, but saying that, this set would probably have been used on long wave, being it's a sort of maritime set. I'm not saying a sailor owned the thing, but certainly all the shipping forecasts and that are on Radio 4. And long wave would be easiest to receive, wouldn't it? Let's take out my new old stock lock fit. Let's pop our youngster in. What's done with that? Is it still attached to the meter? Nope. Okay, so that's playing hard to get now. That's decided that it's going to leave the bench because it does not want to be fitted. Stuff drops on the floor all the time here. I want to get another bench. I need to make sure that I've got a little little lip on the edge. The trouble is that does your wrists in, doesn't it? How strange. It's an omen. Don't fit me. I'm gonna disappear forever. Madness. Literally had that here a second ago. And now it's no longer here. Double check it's not falling on the floor. The pen's on the floor. We're finding a little tiny transistor, which is nowhere to be seen. That's crazy. Oh, luckily it's one we got loads of, but that's not the point. Stay there. Don't move. Right, now we have another transistor. Transistor number 2. Would help if the thing was on. Still can't believe that transistor's done a runner. gonna have a quick look over this section with the microscope a minute, because you never know, there might be a dry joint or something that I can't see with the naked eye and all of that jazz. Fairly horrible soldering, but nothing dry as yet. See, the other thing it could be, and I have had it very, very rarely, and that is the trimmer caps. Sometimes they've been screwed down so hard that they'll bite through the dielectric. You know, the little, what do they call it? What's that clear stuff? Mica washer. They'll break through the mica washer. Right, let's go again. Are you ready for round 75? We got it working, John. It's working, but not great. Not great. Christoph. Dee-dee-dee-dee. Yeah, Anthony. It's all a pain in the backside, but let's, you know, this could have cured it. I doubt it, but you know, it could have cured it. It could be good to go. Oh, it's certainly dying. We're back to where we were before, I think. Let's trim radio 2 back in a minute.
everyone around to the downstairs.
It's just totally dying on the right hand side now. We've had 3 different transistors in there now.
Wagging all night long about my battery life. Tricky woman. Sadly. Object lesson. Of my suspect fire lover wandering up into the bush, the market square. My early morning peep shows the breaking day. Someone forgot to rock my room.
So that transistor's definitely better than the other one. It's got a better range on it. But that's me just touching the aerial coil again. What on earth is going on here? Why have we got this issue? Why is there nothing? I don't know. I don't know now. Is it that thing now? If we add some capacitance into that other one that's 68, should be 90. That's not a huge amount of capacitance, is it? 68 should be 90. What do we need to add in? 60, 70. So we need to add in some like 20 odd picofarads. $22 picofarads maybe. Let's try if I pop that across the other one so it's in parallel. 22. Let's just mark 22. See if I can find. There's something stopping the radio halfway across. 22 picofarads there. I just wonder whether someone's been messing with it and changed a capacitor out of it unnecessarily. You know, it could be done, I suppose. Doesn't look like it's been changed, but with time everything can look similar, can it? So let's have a look. Where was it? It was there. Oh, hang on. No, it wasn't. It was the one at the top there, wasn't it? That I messed with. It was this one. Ah! Ooh! Interesting, I've got RF now. Has somebody been stitching me up? could be totally barking up the wrong tree, but I just put that little 22 across that 68, and now we have a bit of action. So maybe it was a bit of a godsend that we took that out. I don't know. I'm still clutching at straws here, because obviously my finger's on this as well, which is going to put a bit of capacitance in it. But that's solder it on temporarily. What are we not connected to now? That. So, well, that's strange, because when I had my finger on that, maybe it was this. That's made absolutely no difference at all. I thought I cracked it then. Oh, that's the other transistor's turned up. Look, he's come to play. I thought I cracked it then for a minute. But no, I haven't. Let's change the tuning a little bit. How strange. Let's chuck our 1800 kilohertz back in there a minute. Which was, what did we say? It was 247, wasn't it? I can't remember now. Seems like a year ago. No, it's 174, wasn't it? Was what it wanted. I mean, I can shove a massive signal through it, but it's not really telling us anything, is it? Where do we go now? Where do we go now, Graham? Unusual little where's that blue and white one go? Not a problem. I'm just trying to rack my brains here as to what could be wrong. It's got to be something in this section, but just don't know what. I just don't know what. Martin's off. Cheers, mate. Yeah, we'll get there, Invincible. Why would you mess with yours, Rob? Don't touch yours, mate. If it's working, leave it. Yeah, it does, Anthony, but what? There's not many things left that we haven't checked. I mean, I'm just racking my brains. It could be these dodgy old resistors, but R2 and R3, R2, R3 and R17 are favourite to have a look at. If we look up here, you know, these are biasing the base of this transistor. Look, R2 and R3, R17's on the output, and we've got C6 as well. All of these things, I suppose, could affect frequencies. I'm not that au fait with oscillator circuits. I mean, they all look laid out in a very similar fashion. C2, C4, anything in this circuit is worth pulling. So far we've obviously had TR1 out, so we know that's good now. We've put 3 different ones in there and they're all pretty much the same, apart from one which had low gain. The one I've got in now I think is performing best. C6 and C2, C4, they're not specific values. I think maybe the resistors are more likely to be a problem, but there's not really any resistors in this sort of part of the circuit. You know, we've got R1 there. Is that switching in the power R1? But then we know we've got the correct voltages pretty much on this transistor. So that doesn't look like that's the problem. Let's pull R2, R3 and R17 a minute for a look. I think that's a good starting place. R2, R3 and R17. Because something's wrong in this oscillator for sure. Let's put those to one side. Let's find out where R2, R3 and R17 are. R2 and 3 first. R2 and R3 are side by side, but on the edge of this board. Those two. So we've got a brown, grey and orange and a brown, black and orange. Alex Dockin, how are you doing, mate? Yeah, no problem, Alex. I've got a couple people have sent me messages actually requesting 2001Ds to be fixed. I've just finished Jerry's 2. I've got another one in for Brian. I've got an SW77. I've still got Pro 80 for Frank and Vincent to do. And this one for John. And I'm going to skip to the loo again. I'll be back in a sec. Sorry about that. You know what it is? When you get into these things, you get the beer down your neck, it just goes right through you. Right. Piano. It is the local oscillator. Well, Aaron's off. Catch you soon, Aaron. Welcome back, Baz. Yeah, we are. It's just dying. It gets to sort of just past radio 4 at some 200 kilohertz, then it just dies a death. So I'm just having a look through the oscillator circuit just to see if there's something that's causing us problems there. And we've got these horrible old carbon comp resistors in circuit. The ones shaped with the end caps on them, they're a pain in the backside. They have been known to cause problems. Right, what's this one then? So it's probably not the same as what's in the manual, because nothing does seem to be. So this is brown, grey and orange. So let's get my circle of truth down. Let's dial in brown, grey and orange. According to that, brown, grey, orange should be 18K. So let's see what Uncle LCR says, being that we've done the probes on this just now. So this is probably one of the more accurate ones. I don't trust the probes on my other meter. I need a new set of probes. Are we 18K? $23K nearly. What does the circuit say it should be? Just for a laugh, like, you know, that's R2. Our circuit says it should be 18K. Okay, well, it's not 18K. It's nearly 22.5K. The thing is, oscillators can be finicky as hell. You don't need it to be much out for it to stop working. $18K is going to be one of them sizes that nobody ever uses anymore. And I'll have to go deep again. Stop it. All my storage boxes are fighting each other here. They all want to come and see me, but they can't. 18K. Is that a thing? No, it doesn't look like it's a common value. I've got lots of Ks, but no 18. I can probably do 18.2K in series. Really? Have we not got an 18K? 15K? $100K? 4K. 8K, 47K. Someone needs to have a word with Hacker and tell them they need to use more commonly available components in their radios. If someone can drop them an email for me. You can pop them an email over. Ben, how you doing, mate? Morton Rockers. Bad Joe, how are you, mate? Let's go deeper. We're going to have to go into the archives to see if we can find an 18K. 1.8K. Ooh, 18K. Is there one in there or is it empty? Oh, I've got one pull in there. One that's been pulled from something else. Scraping the barrel a little bit, but let's have a look. What does it read? Incidentally, I need to add 18K resistors to my list of things that I'm never going to ever use. Because clearly I've only got one left in the whole planet. Let's see what this one reads. I wouldn't have pulled this and kept it for no reason. Oh, 18.1K, look. Clearly kept that for a reason. That's going back in then. I mean, we're clutching at straws, really. You know, I just got a funny feeling it's a coil somewhere, you know? But I'm guessing. Because this is going to mess up our alignment on medium wave as well now. You know that, don't you? I should disconnect all this lot really rather than have it hanging off, but you know, we're nearing the end of the stream at some stage. We've got to finish today, really. This is John's fault again. John, this is all your fault, John. You do this. You send me these impossible tasks. He's renowned for it, John. I don't mean it, John, you know that. I'm only messing. Not quite. We did find out why it wasn't working though, which I was quite pleased about last week. So if you've not seen last week's video, you need to watch that one. That was a fair bit of fault finding went on to find a sort of non-standard fault, really. All the usual things that you think it could be, it certainly wasn't. I was concentrating on soldering this leg in, which doesn't want to be soldered because it's been painted by the looks of it. And lo and behold, the other one drops out. Yeah, I really didn't want to take the solder, that one. But it has. So let's pull the next one beside it a minute. I'm going to do both of these two and then I'm going to test it again. So this is the other bias one. So this one is a brown, black, orange. Brown, black, orange, 10K. What do you think it's going to read? We're doing resistor bingo. 10K. It's gone 2.2K high. What did I say it was? 10K? Is that what it says in the book as well? Yeah. Surely 10K is the standard one, isn't it? Surely 10K. Yes, it is. Yes. Yes, sir. Got some sort of period looking ones there. Let's stick one of those in. Let's see what it's measured first. .9. Give it a little bit of a zhoosh up because it is a new old stock. Right. Let's solder that one in. Let's see if that's made any difference. There is one more that was on my hit list there, of course, but we've run out of time pretty much. Right. Let's see if those two being out of spec. The problem is all of the resistors in that section are going to be out of whack. It's not massively, really, but potentially it could be enough to throw the oscillator out. Right, let's get to grips with where we are here, because we've got a wire disconnected there. That is going to that one there. So we can listen to it, the audio, because I've got no speaker connected, so my signal tracer is currently my speaker. Nothing else touching, right phone hole. We've got RF noise over here. But we've got no radio 2, radio 4 even. But then I have twiddled stuff, so let's just twiddle it back to where it was. Still deaf over here, but it has picked up. But we have now lost radio 2. That's a massive signal, isn't it? Amplitude 10 millivolts.
From coast to coast, much of the United States is coated in snow and ice. This is certainly a rare storm in that it does have a very big scope. We are talking about this storm system taking up a good swath of the country, millions of Americans feeling the winter chill. From New Mexico to New York, all the way up to Maine, a state of emergency has been declared in at least 23 states. In Mississippi in the south, snow clouds are battling to clear the roads, only to find them blanketed once again within minutes. Residents have no choice. More than 10,000 flights. Elsewhere, venturing up. Treacherous.
Get on the road, Dougie.
No, still dead. We've got. It sounds like we've got a bit more RF noise there, but not a fantastic amount. So we still haven't cured that. Something is going on there somewhere. Mind you, I have got that. Let's just lift the leg of that thing that I put on a minute, just in case we are okay now, and that's our issue. Just in case, you never know, because I have added the capacitance in there. Still dying, isn't it? I mean, I think this is going to be a to be continued, because I did get a little bit more RF noise adding those two in, but still dying, so it hasn't really made any difference. I don't really know what else to check. but I will try and revisit that maybe in the week. So let's just catch up with the chat. Gia, how are you doing, mate? A broken jukebox on board an old coastal steamer. Whoa, are you going to do that, Gia? No worries, John. Rob will do it for me. What's Rob going to do for me? Where's Rob gone? Where is Rob gone? He's back there. We don't want any hacker messing with Rob. Whoa. Use an oscillator, Anthony. Use an oscillator and see what it's doing when you're tuning across the band. Dave Rhodes. Thanks, Dave. Yeah, there's loads of noise here. Badger. There's so much noise in here. It's really difficult to work on AM lower frequencies. Yeah, you've got to test it while at sea. Wouldn't be right, Alice. The trouble is you'd probably get seasick then, wouldn't you? Well, there we are, people. I mean, I keep moving this as well. That doesn't help much. It matters, does it? Whether that band spread does affect it on medium wave and long wave, I don't know. It's a very strange... Well, it's not strange. I mean, end of the day, if an oscillator is playing that, that's what it does. It dies. It dies a death. It's worth connecting it to an external aerial as well to see if it does any different. Because, you know, I'm still thinking maybe something with the aerial coils, but you know, the aerial or the oscillator coil. I'll have to get my thinking head on that, because I mean I have got that spares Sovereign 2. If it uses the same circuit, which it probably does, it obviously hasn't got all the shortwaves in it, but if it uses the same oscillator components, it might be that I can swap out some of the other bits to rule them out or measure them at least. Or I could get one to use the doodle bug, the curve bug doodle bug. Yeah, it is. But is it the low frequency though? Because it goes. I get confused with these. Yeah, it is the low frequency, isn't it? I think. Yeah, so 1800 meters is lower than 1200 meters. It really does confuse me, all this meters business. Why can't I just tell you why can't I just say the megahertz? It's a damn sight easier. But yeah, they've still got to work in meters on me. Yeah, it is unusual, but I'm trying to think. I have had it before, a long time ago. Not recent. Not within the last 5 years for sure. But it could be a combination of any of these components causing it. Yeah, I will get my head in the manual tonight anyway and see if I can work it out. Who knows? Who knows what's wrong with it? Joe's saying series capacitance that might have gone low out of the low. Because what if the local oscillator is taken off at spurious high frequency? Dwarf, cheers, mate. RF part of the tuning cap. A good thought. That's something I've not thought of. Cheers, Ben. Thank you. There we are, people. That's it for today. Hope you've enjoyed that struggle. Always is a struggle. It's just me thinking that's going to be dead easy and I'm going to be twiddling my fingers for something to do. But surely that wasn't the case, was it? So back to the manuals for me. Cheers, everybody. Have a good week, and I'll see you next Sunday. Might not be on this. You never know. It might be. We'll see. We'll see. Bye for now.